In this example, we're going to demonstrate how we can use the Pythagorean theorem to find the missing length of a leg. In the first examples, we just found the missing length hypotenuse, but we can also, as I said, use the Pythagorean theorem in a right triangle to find the missing leg. So again, I'm going to verify we have a right triangle. We know 2 out of 3 parts, which is imperative. If you're going to use the Pythagorean theorem, you need to have 2 out of 3 parts unless it's an isosceles triangle. In this case, we don't, so we're going to apply the c squared equals our sum of the 2 legs squared. We know that our hypotenuse across from our right angle is 25, so we have to take 25 and square it. It has to equal, since it has the variable a missing there, I'm going to put a squared, which is going to let 7 be the value for b. So b is going to be replaced with 7, so 7 squared. So we've got to take 225 and square it, and if I'm not mistaken, that's 625 equals a squared plus 49. Now we've got to solve this for a squared. In order to solve this for a squared, we're going to have to be able to move the 49 over. So we want to subtract 49 from both sides. So now we have a squared equals, and well, 15 minus 9 is 6, and 11 minus 4 is 7, so 576. And then we're going to have to get rid of our squaring. To undo squaring, we square root, so a is the square root of 576. And I think I recognize that as a perfect square, but what we can do is we can run our second square root. I'm not sure I got that. Square root of 576, enter, and it's 24. So our length of our missing leg is 24 feet. Another demonstration of how to use the Pythagorean theorem to find a missing leg. In the second example, we're still got a right triangle, and we know 2 out of 3. So right triangle, we know 2 parts out of 3. So this Pythagorean theorem works well. C squared equals a squared plus b squared. Substitute in the values for your hypotenuse and the leg. Your hypotenuse is 4, so 4 squared has to equal. This time we know a, and a is 2 squared, plus b, which is b squared. We're going to simplify our squareds. 16 equals 4 plus b squared. We're going to have to undo this positive 4. We're really adding 4, so to get rid of that, we'll subtract 4. That's going to leave us with 12 is equal to b squared, which means b has to equal the square root of 12. And then we can run the calculation on the square root of 12. So to do some mental math, I'm punching this in. The square root of 12 has to be bigger than 3, but smaller than 4, so it better be a number between 3 and 4. And it's 3.46, or if we round to the nearest tenth, it's 3.5. At some point, we'll have to have a discussion on how to put these in simplest radical form. At some point, we're going to have to say, well, that square root of 12 is the same thing as the square root of 4 times 3, and we'll have to eliminate all perfect squares into the radical. And the square root of 4 is 2, so it ends up being 2 times the square root of 3, which is equivalent to the decimal that we just had, 3.5. But this is called simplest radical form, and that would be another time, another place where we'll have to make sure that we can master that skill.